Hello, welcome to my channel Nightlight Science Stories. Take a deep breath and listen to the silence around you. Perhaps you hear the ticking of a clock or the distant hum of the city. Everything seems still, doesn't it? But at this very moment, you are drifting inside a massive, invisible river. We call it time. Most of us think of time as the hands on a clock, steady, unwavering, and equal for everyone. We assume a second for us is a second for the universe. But 100 years ago, Albert Einstein looked up at the sky and realized a terrifying truth. Time is not fixed. It flows like water. It can stretch, bend, and in some places, stop completely. Tonight, we drift towards the source of this river. Scientists call it the fabric of space-time. But to understand it, we must first accept that our intuition is wrong. We feel time passing at a constant rate, but this is an illusion created by our biology. In reality, time is relative. It depends entirely on how fast you are moving and how close you are to a heavy object. This is time dilation. It sounds complex, but it follows a simple poetic rule. The heavier the mass, the slower time flows. The earth is heavy, so it drags time down with it, like a stone on a stretched fabric. Think about this. Your head is technically older than your feet. This is not a metaphor. It is a proven fact verified by the most precise atomic clocks in the world. Because your feet are closer to the center of the earth, gravity pulls harder on them, and time moves a billionth of a second slower there than it does for your head. In a single human lifespan, this difference is invisible. But the higher you go, the faster time runs. If you lived on top of Mount Everest, you would age slightly faster than someone living at sea level. Gravity is not just pulling your body down. It is pulling time itself down. You might think these are just theoretical numbers, but your daily life depends on them. The GPS satellites orbiting the Earth right now are moving fast and are far from gravity. Their clocks run faster than the clocks on your phone. If engineers didn't program them to mathematically correct this time drift every single day, your map applications would fail within hours, showing you kilometers away from your actual location. Einstein's equations are guiding you home every night. But gravity isn't the only thing that warps time. Speed does too. There is a cosmic speed limit in our universe, the speed of light. Nothing can travel faster than it. And here is the paradox. The faster you move through space, the slower you move through time. Imagine you are in a train moving close to the speed of light. For you, inside the train, everything feels normal. You drink your coffee, you read a book. But for someone watching you from the platform, you are moving in slow motion. Your coffee pours like thick honey. Your pages turn over minutes. This leads to the famous twin paradox. If one twin stays on Earth and the other travels to a distant star at high speed, when the traveler returns, they will find their sibling is an old person, while they have barely aged. They haven't just traveled through space. They have traveled into the Earth's future. Time travel to the future is scientifically possible. We are doing it right now, just very slowly. But to see the true power of time, we must leave the Earth. We must go to a place where gravity is so intense that it breaks the clock entirely. We are approaching a black hole, a dead star that has collapsed under its own weight, creating a puncture in the fabric of reality. As we get closer, the stars behind it begin to smear and bend, forming a ring of light. This is gravity acting as a lens. But the real magic happens to time. Here, the river of time turns into a waterfall. If you were to hover just above the point of no return, Every second that ticks on your watch would equal hours, days, or even years back on Earth. This boundary is called the event horizon. It is the edge of the waterfall. Once you cross it, not even light can escape. But let's imagine you fall in, while I watch you from a safe distance. What would I see? This is where the illusion becomes haunting. As you fall closer to the black hole, I would never see you cross the line. From my perspective, you would slow down. And slow down until you freeze completely at the edge. You would become a frozen image, fading to red and then into darkness. To me, you are stuck in time forever. But from your perspective, the experience is radically different. You wouldn't freeze. You would cross the horizon without hitting a wall. You would continue to fall. But as you look back at the universe you left behind, you might see something incredible. Because time outside is moving infinitely fast compared to you, you might see the entire future of the universe play out in fast forward. Stars dying, galaxies colliding, the end of all things. All happening in the blink of an eye as you fall into the darkness. Inside the horizon, physicists believe that space and time swap roles. Space becomes a one-way street. You can only go down towards the center. And time? Time becomes a physical dimension you can traverse. But this is where our knowledge ends and mystery begins. We have reached the bottom of the river. But if time can slow down and stop, can it also flow backward? Or is it a one-way arrow marching towards disorder? In the next part of our journey, we will explore the arrow of time and the chilling concept of entropy. Close your eyes and let the river carry you. Welcome back to the river. We have explored how time can slow down and stretch. But there is one thing time never seems to do. It never goes backward. Think about a glass falling from a table. It shatters into 1,000 pieces. Now, imagine the video playing in reverse. The shards lift from the floor, assemble perfectly in midair, and the glass lands gently back on the table. It looks magical, doesn't it? But it also looks wrong. Your brain instantly knows this is impossible. This intuition is the key to understanding the universe's deepest law. Physicists call this the arrow of time, and the force driving this arrow is called entropy. Entropy is just a fancy word for a simple concept: disorder. The universe loves mess. It is much easier to break a glass than to make one. It is easier to spill coffee than to put it back into the cup. There are infinite ways for things to be disorganized, but only a few ways for them to be organized. Because of simple probability, the universe naturally flows from order to chaos, from the past to the future. Think of an ice cube melting on a hot summer day. The structured water molecules break apart and become a puddle. You never see a puddle spontaneously freeze into a perfect cube under the hot sun. This one-way street is what gives us the feeling of the past and the future. The past is low entropy, ordered, compact. The future is high entropy, chaotic, spread out. We remember the past because it is already broken. We cannot remember the future because the glass hasn't shattered yet. We are prisoners of entropy. But this leads to a disturbing question. If the universe is constantly getting messier, it must have started in a state of perfect order, a state of zero entropy. We trace this arrow back 13.8 billion years to a single moment, the Big Bang. At that exact moment, the universe was incredibly small, hot, and organized, like a tightly wound clock mechanism. Since then, the clock has been unwinding, expanding, cooling down. Every star that burns is increasing the universe's entropy. Every breath you take contributes to the chaos. This implies that the universe has a battery life. And one day, that battery will run out. This is the theory of the heat death of the universe. It is not a fiery apocalypse. It is something much more peaceful and much more haunting. Billions of years from now, the last star will burn out. The last black hole will evaporate. The universe will continue to expand, but there will be no light, no heat, and no life. Just a cold, dark, and infinite soup of particles, drifting in silence forever. Ludwig Boltzmann, the man who discovered this statistical tragedy, was so tormented by his own equations that he fell into despair. It is a heavy burden to know that everything is destined to fade. But there is a twist in the story, a loophole in the math. Quantum mechanics suggests that in an infinite amount of time, anything that can happen will happen. If you wait long enough in that eternal darkness, particles might randomly bump into each other. This brings us to the Boltzmann brain paradox. It is statistically more likely for a single conscious brain to spontaneously form out of the chaos of space, complete with false memories of a life, than for an entire universe like ours to evolve. Are you sure you are a real person, sitting in a room watching this video? Or are you just a fleeting consciousness that materialized in the void for a split second, hallucinating this entire reality before dissolving back into nothingness? It sounds like a nightmare, but the math doesn't rule it out. Let's step back from the madness. Let's return to the flow of time we understand. We perceive time as continuous, but is it? When you watch a movie, you see smooth motion, but you know it is actually 24 still images flashing per second. Could our reality be the same? Is time granular? Physicists talk about the Planck time, the smallest possible unit of time. It is unimaginably short. If you sliced a second into a billion pieces, and then sliced one of those pieces into a billion more, you wouldn't even be close. Could our reality be the same? Is time granular? Physicists talk about the Planck time, the smallest possible unit of time. It is unimaginably short. If you sliced a second into a billion pieces, and then sliced one of those pieces into a billion more, you wouldn't even be close. And if the computer lags, do we experience déjà vu? We drift through these moments, unaware of the machinery beneath the surface. We trust the flow. We trust that tomorrow will come. But as we end this part of our journey, remember this. Entropy may predict the end of the universe, but it also allows for life. Without the flow from order to chaos, nothing would happen. No sun would shine, no heart would beat. We are surfing the wave of disorder, and it is a beautiful ride. In the next chapter, we will dive even deeper. We will ask, is the past really gone? Or is it still out there, waiting to be visited? The concept of the block universe awaits. Rest your eyes. The river continues. We have spoken about the river and the arrow. But what if I told you that the river isn't flowing at all? Imagine a movie reel. When you hold it in your hands, the beginning, the middle, and the end all exist at the same time in that plastic roll. You are the one watching it frame by frame, creating the illusion of motion. But the characters in the movie don't know the end is already written. Many physicists believe our universe is exactly like this reel. A static frozen block where every moment exists simultaneously. This is called the block universe theory. Imagine the entire history of the universe from the Big Bang to the final heat death as a giant solid loaf of bread. Every slice of that bread is a moment in time. The dinosaurs are still roaming on their slice. The pyramids are being built on another. And you, reading this right now, are on your specific slice. The dinosaurs didn't disappear. They just occupy a different coordinate in the block, just like New York is at a different coordinate than Tokyo. So why do we feel the flow? Why does the past feel gone? Think of your consciousness as a spotlight in a dark room. The room is full of furniture, paintings, and objects. They are all there, always. But you can only see what the spotlight illuminates. As the light moves across the room, you say, "That chair is in the past now," or "I am approaching the table." But the chair didn't vanish. The table didn't just appear. Only your focus moved. This moving spotlight is what we call the now. This perspective changes everything about how we view loss. When Albert Einstein's best friend, Michel Besso, passed away, Einstein wrote a letter to his family. He didn't offer empty prayers. He offered physics. He wrote, "Michel has departed from this strange world a little ahead of me. That means nothing." For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion. In the block universe, no one is ever truly gone. They are just back there. If we could step outside of time and look at our universe from the fourth dimension, we wouldn't see people as moving 3D objects. We would see them as long, static geometric shapes, like a snake or a worm, stretching from birth to death. Your baby self is at one end of the snake, your elderly self is at the other, and your current self is just a cross-section in the middle. You are not a fleeting moment. You are a complete, four-dimensional structure that exists permanently in the architecture of reality. But this crystal prison comes with a heavy price: free will. If the future is already there, waiting for the spotlight to hit it, does that mean your choices are an illusion? Is the script already written? When you decide to close your eyes tonight, was that decision made by you? Or was it just the next frame in the reel that had to happen? It is a scary thought, but also strangely liberating. If the movie is already filmed, you don't need to worry about messing up your lines. You just have to play your part. This is the debate of determinism. For centuries, scientists thought the universe was a clockwork machine. If you knew the position of every atom and the speed of every particle, you could calculate the future with 100% accuracy. In a deterministic universe, there is no maybe. There is only what will be. Every beat of your heart, every thought in your mind, is the result of a chain reaction that started at the Big Bang. You are part of the cosmic domino effect. To understand how limited our view is, imagine 2D creatures living on a flat sheet of paper. They can only see lines and shapes. If a 3D ball passed through their paper world, they would see a circle grow from nothing, then shrink and vanish. They would call it a miracle. They would say it appeared in the future and went to the past. But we, looking from above, see the whole ball at once. We are the 2D creatures, trapped in the slice of now, unable to see the whole ball of time. So if the block universe is real, is time travel possible? In theory, yes. If the past is a place that still exists, you could with enough energy travel to it. Just like traveling to Paris, you wouldn't be recreating the past. You would simply be visiting it. But don't pack your bags yet. The energy required to punch a hole in the block is beyond anything we can imagine. And there is one major problem that threatens to shatter this perfect crystal block. A problem called quantum mechanics. But don't pack your bags yet. The energy required to punch a hole in the block is beyond anything we can imagine. And there is one major problem that threatens to shatter this perfect crystal block. A problem called quantum mechanics. This uncertainty suggests that the future might not be written yet, or even wilder. Maybe every possible future is written. Maybe the block isn't a single crystal, but an infinite branching tree. Welcome to the multiverse. We will explore these infinite realities in the next part. Welcome to the quantum realm. If the block universe was a solid sculpture, this place is a shifting fog. When we zoom in deep enough past the atoms, reality loses its certainty. Here, particles don't have a fixed location. They are just probabilities. They are ghost-like waves that exist everywhere at once. They only decide where to be when they interact with something. This leads us to the most famous cat in history, Schrödinger's cat, a thought experiment that reveals the madness lurking beneath our calm reality. Imagine a cat in a sealed box with a device that has a 50% chance of killing it. Until you open the box to check, quantum mechanics says the cat is not dead or alive. It is dead and alive at the same time. It exists in a superposition. Two realities are overlapping in the dark. The moment you open the lid, you force the universe to choose. The wave collapses, and the cat becomes one or the other. But here is the chilling question. What if the universe never chooses? This is the many worlds interpretation, proposed by Hugh Everett. It suggests that the wave function never collapses. Instead, the universe splits. In one timeline, you open the box and the cat is alive. In another, equally real timeline, it is dead. This means that right now, you are constantly branching out. Every decision you make, every coin you flip, creates a new universe. There is a world where you didn't click on this video. There is a world where you made different choices years ago. We are living in a garden of forking paths. This destroys the idea of a single straight river of time. Instead, time is a rapidly growing tree. We are just climbing one specific branch, unaware of the millions of other branches growing right next to us. These parallel worlds are likely separated by a frequency we cannot tune into, just like radio stations occupying the same air but never touching. But sometimes, physics hints that these worlds might interact. Have you ever felt a shadow of a life you didn't live? This brings us to quantum immortality. It is a controversial and slightly terrifying idea. If consciousness can only exist in a living brain, and the universe splits at every moment of death, does that mean you can never truly experience your own end? From your perspective, you might always survive the odds, always waking up in the branch of the universe where you are still alive, while in millions of other branches you have ceased to exist. You might be destined to watch the universe age forever. If isolation scares you, let me offer you a cure: quantum entanglement. Einstein called it spooky action at a distance. Sometimes two particles become linked. If you separate them by billions of light years and change the spin of one, the other reacts instantly. Faster than light, instantaneously. It defies all logic of time and space. It implies that at a fundamental level, space is an illusion. Separation is an illusion. Two things can be one, no matter how far apart they are in the universe. If the Big Bang started from a single point, then every particle in your body was once entangled with every other particle in the universe. In a way, you are still connected to the stars, to the distant planets, and to every other living being. We are not isolated fragments drifting in the dark. We are a single, massive quantum web, experiencing itself through billions of different eyes. Time creates the illusion of separation, but the connection remains beneath the surface. But if there are infinite worlds and infinite timelines, where is all this data stored? Some physicists argue that the universe behaves suspiciously like a computer code, a digital physics reality. If time is just the refresh rate of the screen, and space is just the pixel density, then who is the programmer? Or are we the code writing itself as it runs? The precision of the universe's constants is so perfect, it feels fine-tuned. We have traveled from the event horizon to the quantum foam. We have seen time stretch, stop, and split. But we have ignored the most important variable in this equation. The only thing that proves time exists at all. You, the observer. Without a mind to perceive it, does time actually pass? Does a falling tree make a sound if no one is there to hear it? Or is time just a biological hallucination created by our brains to make sense of the chaos? In the next chapter, we will turn the camera inward. We will explore time and the mind. Why does childhood feel like it lasted forever, but adulthood flies by? Why does fear slow down the clock? And most importantly, is it possible that consciousness exists outside of time entirely? Prepare yourself. We are leaving the realm of physics and entering the realm of experience. The river flows into the ocean of the mind. We have looked at time through the lens of telescopes and equations, but the most complex time machine isn't a black hole. It is sitting right inside your skull. Physical time is rigid, but psychological time is elastic. Have you noticed how a boring meeting feels like an eternity, while a joyful holiday vanishes in a heartbeat? This is not just a feeling. It is a fundamental feature of how your brain processes reality. We don't record time. We construct it based on information density. Your brain is not a clock. It is a storyteller. It judges time based on how much new data it has to process. When you are afraid, time seems to slow down. This is called time dilation, but biological, not physical. Your amygdala goes into overdrive, recording every detail in high resolution. Because you have more memories of that single second, your brain tricks you into believing the moment lasted much longer than it actually did. It is a primitive survival mechanism. Why did summers feel endless when you were a child, but now weeks blur into months? This is the proportional theory. When you are 5 years old, 1 year is 20% of your entire life. It is massive. But when you are 50, 1 year is just 2% of your existence. It becomes a tiny fraction. But there is a deeper reason involving novelty. For a child, everything is new. The brain works hard to encode the color of the grass, the taste of ice cream, the sound of the ocean. As we age, the world becomes familiar. The brain becomes efficient. It stops recording the details of your daily commute because it has seen them 1,000 times. It runs on autopilot to save energy. This lack of new memory markers makes time collapse. If you want to slow down time, you must break the routine. Travel to a new place. Learn a new skill. Force your brain to pay attention again. A routine life is a fast life. Novelty is the only brake pedal we have against time. Here is a disturbing fact. You have never actually experienced the present. You are always living in the past. It takes time for light to hit your eyes, for signals to travel to your visual cortex, and for your brain to assemble the image. Neuroscientists estimate consciousness lags about 80 milliseconds behind reality. By the time you perceive this moment, it is already gone. You are constantly watching a live broadcast of the world with a slight delay. You are trapped in the immediate past. This delay creates strange illusions. If you touch your nose and your toe at the same time, you feel them simultaneously. But the signal from your toe takes longer to reach your brain than the signal from your nose. Your brain waits, collects the data, and then edits the timeline to make you feel like it happened at once. It lies to you to create a smooth experience. Your reality is a carefully edited post-production video, not a raw feed. The now is a fabrication of the mind. Think about sleep. It is the closest we get to time travel. You close your eyes, consciousness shuts down, and you teleport 8 hours into the future in a single instant. Where were you during that gap? If time is measured by change, and your consciousness registered no change, did time exist for you? This suggests that time requires a self to be experienced. Without an observer to count the seconds, the universe might just be a static, timeless ocean waiting for a witness. In 1962, Michel Siffer isolated himself in a dark cave for 2 months without a clock. He wanted to find the body's natural rhythm. Quickly, his sense of time dissolved. When he emerged, he thought it was mid-August, but it was actually mid-September. He had lost an entire month. His internal clock had drifted, stretching days into 48-hour cycles. Without external cues like the sun, our grip on time slips away into the void. It shows how fragile our temporal reality is. Our relationship with the past is also deceptive. We think our memory is a video library, where we can pull out a tape and watch it exactly as it happened. But neuroscience shows that memory is creative. Every time you recall a memory, you are not playing it back. You are rewriting it. You modify the colors, the emotions, and the details based on how you feel right now. The more you visit a memory, the less accurate it becomes. You are remembering the last time you remembered it. Sometimes, this machinery glitches. We call it déjà vu, that eerie feeling that I have been here before. Some theories suggest this is a synchronization error in the brain. Perhaps one eye records the scene milliseconds faster than the other, or the short-term memory accidentally writes directly to long-term memory. You feel like you are remembering the present moment. It is a crack in the illusion, revealing that your timeline is just a fragile construct of neural firing. Certain chemicals or states of meditation can dissolve the perception of time entirely. People report experiencing eternity in a few minutes. This happens when the brain's default mode network, the part responsible for the self, quiets down. When the I disappears, time disappears. This aligns with ancient spiritual beliefs. Time is an attachment of the ego. If you stop the narrative in your head, you step out of the river and float in the eternal now. There is a specific anxiety called chronophobia, the fear of time moving forward. It is the realization that we are on a conveyor belt moving towards a drop-off. But this fear only exists because we view time as a resource we are losing. What if we viewed it as a landscape we are traversing? You don't lose the road you have already driven on. It is still there behind you. Your childhood is safe. Your memories are safe. Nothing is lost in a block universe. Do animals experience time? A fly sees the world in slow motion because its visual processing is much faster than ours. That is why they are so hard to swat. To a tortoise, we must look like frantic blurs of energy. Time is not a universal constant. It is a biological frequency. Every species is tuned to a different station. We are locked in our human tempo, unable to comprehend the slow rhythm of a redwood tree or the frantic pace of a hummingbird. We are alone in our timeline. There is one state where we can escape the tyranny of the clock, the flow state. When you are deeply absorbed in art, sports, or work, you lose track of time. The prefrontal cortex shuts down. You become the action. In this state, you are closest to the nature of the universe's pure process. without the burden of the past or the anxiety of the future. It is a glimpse of liberation. It is the only time we are truly free from the ticking clock. There's a final cruelty to biological time. The older we get, the faster the years seem to accelerate. It feels like slipping down a slope, but knowing why this happens gives us power. If routine is the accelerator, then curiosity is the brake. We cannot stop the clock, but we can thicken the moments. By seeking awe, by remaining curious, by refusing to live on autopilot, we can stretch our perception of the time we have left. We can make a year feel like a decade. Ultimately, we try to cheat time through legacy. We build statues, write books, and have children, hoping a part of us survives the entropy. We are terrified of being forgotten, of falling into the deep time where no names exist. But look at the stars, even they will die. The desire for permanence is a fight against the fundamental nature of reality. Perhaps the beauty of a flower lies in the fact that it doesn't last. Its brevity is what makes it precious. So where does this leave us? We have explored gravity, entropy, quantum realms, and the brain. All clues point to one suspicion: time is a stubborn illusion. It is a user interface created by our biology to help us survive in a complex universe. Real reality might be a timeless, static ocean of being. We are just the waves that rise and fall, thinking we are moving, when we are just water changing shape. Accepting this can be terrifying, or it can be the most peaceful thought you ever have. If time is an illusion, then there is no rush. There is nowhere to get to. You are already there. The anxiety of running out of time dissolves when you realize the clock is just a tool, not a master. You can stop fighting the current. You can just float, breathe, feel the weight of your body. This moment is all there is. We are nearing the end of our journey. We have dissected the seconds and analyzed the eons. But there is one final question we haven't answered. How does it all end? Not just for you or the Earth, but for everything. What lies at the absolute end of the timeline? And is it truly an end or a new beginning? Theories suggest a cycle, a heartbeat, a cosmic lung breathing in and out. In the final chapter, we will travel to the distant future, past the death of the sun, past the era of black holes, to the big freeze and the potential big bounce. We will ask if the universe is eternal. Prepare for the ultimate scale. Prepare to witness the end of time itself. Sleep tight, for the final dream is about to begin. We are entering the final chapter of our story. We have traveled from the first second of the Big Bang to the complex machinery of the human mind. But the river of time flows towards a destination that is difficult to comprehend. Astronomers call it the degenerate era. Trillions of years from now, the era of starlight will end. The universe will have expanded so much that galaxies will drift apart, no longer visible to each other. The night sky will be completely black. It is a lonely thought, isn't it? But there is a quiet beauty in this silence. The universe isn't dying in a violent explosion. It is simply going to sleep. The last stars, called red dwarfs, will burn their fuel very slowly, glowing like dying embers in a campfire for trillions of years. Civilizations in this era will huddle around these fading lights, telling stories of a time when the sky was full of bright, burning stars. A time that we are living in right now. Eventually, even the red dwarfs will fade. The universe will be dominated by black holes, but even they are not immortal. As Stephen Hawking predicted, black holes slowly leak radiation. Over unfathomable eons, they will evaporate and disappear into the void, one by one. This is the heat death. a state of maximum entropy where temperature is uniform and energy can no longer flow. Time, for all practical purposes, will cease to have meaning. If nothing changes, time cannot be measured. The clock stops because there is nothing left to tick. It seems like a depressing end, a final curtain closing on existence. But physics offers us a secret door, a theoretical possibility that turns this end into a new beginning. Sir Roger Penrose proposed a model called conformal cyclic cosmology. He suggests that the end of our universe is mathematically identical to the beginning of a new one. Penrose argues that when the universe becomes cold, empty, and massless, it loses the ability to keep track of scale. Big and small lose their meaning. In this state, the infinite cold void of the far future might be the same thing as the infinitely hot singularity of a Big Bang. The death of our universe could be the spark that ignites the next one. We might not be living in the first universe, but in one of an infinite chain of universes. Imagine a phoenix rising from the ashes over and over again. This is the cyclic universe. It means that time isn't a straight line, and it isn't just a block. It is a circle, a loop. This aligns with ancient philosophies and the concept of the eternal return. If time is infinite and matter is finite, then eventually the particles that make up you will come together again. It might take a googolplex years, but it will happen. Friedrich Nietzsche asked, "What if a demon crept after thee into thy loneliest loneliness and said, 'This life as thou now livest it, thou shalt have to live it once more and innumerable times more'? Would you be terrified, or would you welcome it?" This is the ultimate test of life, to live in a way that you would be happy to repeat forever. In a cyclic universe, every hug, every tear, and every sunset is eternal. Nothing is ever truly lost. This perspective removes the fear of death. We are not vanishing. We are just parts of a cosmic melody that plays on repeat. We are the universe experiencing itself, learning about itself through billions of different eyes. We are the way the cosmos knows it exists. As Carl Sagan said, "We are made of star stuff. We are just stars that have cooled down enough to think, to wonder, and to sleep." You are the universe taking a nap. So as you lie in your bed tonight, feel the gravity holding you down. That same force binds the galaxies together. Listen to your breath. That rhythm is the echo of the first expansion. You are safe. You are right where you need to be in the block of time. There is no need to rush, for the circle is long and there is time for everything. The past is a memory, the future is a dream, and the now is your home. We have journeyed through the event horizon, walked the forking paths of the multiverse, and stared into the face of entropy. We found that time is a mystery that may never be fully solved, and perhaps it shouldn't be. A magic trick is only magical until you know how it works. Let the mystery comfort you. Let the unknown be a blanket that keeps you warm in the vastness of the dark. Thank you for traveling with me tonight. If this story made you think or helped you find a moment of peace, you can stay with us. There are many more stories hidden in the dark. But for now, let the river of time carry you gently into sleep. The universe will still be here when you wake up. Good night, and sweet dreams in the eternal now.